everyone, my name is Alina. I'm a developer advocate for GraalVM at Oracle Labs, and I'm super excited to be here at Devnexus. I've heard a lot of great things about this conference, and I hope that maybe next year, when everything will be different, we will be able to meet together in real life and have a normal conference like we used to. But for now, I'm glad to meet you online, and let's dive into this talk about building fast and efficient Java microservices with GraalVM. So a very quick recap for those of you who are maybe less familiar with GraalVM. GraalVM is a high-performance virtual machine. It can execute all those different languages that you see here on top and also work in a context of different environments, for example, those that you can see below. So GraalVM can run in normal Java JVM applications. It also can run languages like JavaScript and Ruby. And maybe if you're interested in running things like R and Python, so maybe if you're doing statistics, machine learning, data science, these kind of things, you can also do it on GraalVM. And GraalVM also includes an LVM runtime, so running languages like C, C++ is also possible. Now, talking about where you can use GraalVM in what context. So in the context of OpenJDK, that's the way how GraalVM runs your Java applications in JIT mode. And migration there is very easy. What it means from user's perspective is that you just replace your JDK distribution with GraalVM and you run your Java applications as you normally would. That's the only thing that changes. And the part that changes is the compiler. So we just replace your top tier compiler in OpenJDK with GraalVM compiler. And that's what is the difference in this scenario. GraalVM can also be used in context of Node.js, and it also, what's quite interesting, can be embedded in different native and managed environments. One of those examples would be in a context of Oracle database. That's an embedding option of GraalVM. And last but not least, it can run applications in standalone mode, meaning that GraalVM will be the only runtime needed for your applications to run. So we'll talk about native image quite a bit in this session. Those are languages and platforms in which you can use GraalVM, and why you could be interested in GraalVM, a couple of things. So it can offer you high performance. This is this JIT mode in which you would use GraalVM compiler to produce highly efficient machine code. Another reason to be looking at it could be if you want to achieve fast startup and low memory consumption for your application, then GraalVM native image is a way to go for you. And one more is that GraalVM can run not only all those individual languages that you've seen in the first slide, but also you can mix and match them and do those polyglot applications with GraalVM, also with good performance. And GraalVM is also open source. Our development is happening on GitHub, so if you're interested in it, you can go there, take a look, see what's happening, track features, or maybe contribute. Now, let's talk specifically about Java microservices. So if you want to run your Java application on GraalVM, there is a choice that you can make. So this is something you get to decide, and it's whether you want to run your applications in JIT mode or in AUT mode, in native image mode. And this is something that I think is quite important because the native image mode is so exciting and so interesting that sometimes people only associate GraalVM with this native image mode. But in fact, there is way more that GraalVM can do for you. And specifically for Java, one thing to remember is that you can also do JIT with GraalVM. And this is something that kind of a choice that you get to make when you are using GraalVM. What it means for you that in JIT mode, you would just use GraalVM as your default distribution and run your applications in JIT mode. And if you want to run applications as native image, there is a little bit more work to do. You can think of it as working with your application into two steps. First, you have a build step, and then you run your application. And the idea there is to move all the heavy lifting, all the expensive operations to the image build step, so that every single time when your application starts and runs, it can do so fast because you already done all this heavy lifting at the image build step. So let's first talk really quick about the JIT mode. So a reason to move to GraalVM in JIT mode, or a reason to consider it for your applications, would be mostly performance. Where this performance is coming from and what kind of performance you can expect for your applications. For that, we can look at this benchmark suite called Renaissance. As you can see, it offers quite a wide range of workloads, which you can look at and maybe find something relevant for your workload and look at it as of a reference point. So here we are comparing GraalVM performance against OpenJDK, and you would see that for many workloads, it offers comparable or better performance than OpenJDK. But of course, to find out the exact numbers for yourself and for your own application, the best way would be just to run a sample workload on GraalVM and measure it, because obviously every application is different. But benchmark numbers like this you can use as your first kind of evaluation reference point when you are considering whether or not to look at GraalVM. And I want to show you a quick demo. I hope this works. So this is running a Java application in JIT mode, and this application is a Java application that also leverages the Stream API. And to see the kind of performance that I can get additionally with GraalVM, what I will do here, I will run it without GraalVM first. So I disable it over here. And what it means effectively, if you're running on GraalVM Community Edition, this will mean that you will be running in an OpenJDK kind of setup, because if you're disabling GraalVM as your top tier compiler, you will be left with your basically default OpenJDK setup. So we are running this application, it's warming up, it stabilizes, and we will measure performance as time it takes for each operation to run. Let's just wait for final iteration to finish. So here we got a score of 285 nanoseconds per operation. And now, second time, I will run it with GraalVM once again, but I will not be disabling GraalVM, so we will see what kind of difference can this compiler bring to the application performance. Let me just fast forward so we don't wait another 40 seconds. Okay, we are done here, and our score in this case is 13.6 nanoseconds per operation average, while the first time it was 284. So this means that for this application, we are using 20x less time, so our performance is much better. Obviously, here I would need to say a disclaimer that everyone's workload is different, and please only use this as a reference number and test it on your own workloads. But the bottom line is that performance improvements like this are possible with GraalVM. And if you're wondering where this kind of performance is coming from, there are quite a few additional performance optimizations that were added in GraalVM as compiler. Some of them are past duplication, optimization-driven inlining, advanced speculations, and so on. And basically, these are the optimization phases that contribute to improving application performance. Okay, see if we can move on. Now let's talk about startup performance. So peak performance is great, but what if I'm more interested in how much it takes my applications to start in terms of startup time and also the resources that my applications are using when they are starting? For that, GraalVM native image is quite a good solution. And what it does, GraalVM native image, is that it takes your Java application and it compiles it into a standalone native executable. This way, you can achieve really good startup time and low memory footprint because this application is already compiled and optimized, and it doesn't require any kind of Java runtime to run. So it's completely standalone. And one more good thing is that it works really well with many Java microservice frameworks. So if you want to get started with GraalVM native image, then trying one of those frameworks is a really good way for you to get started, because they will give you tools and support and just an easy path to get started with GraalVM native images. So how does it work, and what happens when you take GraalVM native image utility and give it your Java application? So what it will do, it will take your application and start analyzing it, trying to find all the reachable code and also running initializations. And it performs this process in iterations until it finds this fixed point and all the code is discovered. So it basically is trying to find all the code that is essential for your application to run and pack this code into this native executable. So only this essential code ends up in the final application, and it's quite small because all the parts of the code that are never used are left out. So what you get in the end is really what is essential for your application to run functionally. And how is it different to running in JIT mode? So when we are talking about startup time, there is quite a lot of operations that are happening when you first run your application in JIT mode. You would need time to load the GVM executable itself. You need to load classes, start interpreting, compiling, collect data, and then at some point after application is warmed up, it can run with optimized compiled code. Well, compared to that, as we discussed, right, that with native image, you first build it and then you run it, and you're trying to remove as many expensive operations as possible to the image build time. It's different because when your application starts as a native executable, it only needs time to start, and it already can run with this optimized machine code, which happened ahead of time. And also, native image makes a big difference in terms of memory footprint, because when you're running in JIT mode, you need to keep around memory for things like GVM executable, application data, and so on. If you're running in native image mode, you only need memory for this executable and the application data. So how do you choose which one you want to do, right? So you have your Java application, you're deciding between JIT and native image mode. So in JIT mode, in GraalVM JIT, for example, you can really optimize well for peak throughput and for reducing max latency. Having that runtime information available is really essential to optimize your application for peak performance. So if those two metrics of performance are important for you, then go with GraalVM JIT. Now, if you're rather leaning towards having fast startup and reducing resources consumption, or maybe reducing the packaging size, which could be important in resources constrained environments, then go with GraalVM native image. So this is how you basically make this decision at this point, but also we are working on GraalVM native image to make sure that you can also achieve and optimize for all those performance metrics with GraalVM native image. Now, let's imagine you're already interested in GraalVM native image and you want to try it, or maybe try other kinds of GraalVM applications. Where do you get started? One thing you can do is to go to our GitHub repo where we contain all our demos and try running those demos. We have demos for using GraalVM native image, for just simple Java performance. We have polyglot demos, so you can really try and find something that is really interesting for you in those applications. Now, if you want to build your application from the ground up, then a good way to go, and especially if you want to use GraalVM native image, so a good way to go would be by using one of those Java microservice frameworks, and I will talk about a couple of them in this presentation. First one I want to talk about is Micronaut. You may know it as a framework that is really good for doing microservices and serverless, but also it's a full stack framework that gives you a lot of opportunities to build applications in Java. And it also works really well with GraalVM native image, so it's a good way for you to get started with GraalVM native image. I will show you an example of actually a Micronaut application, and on this application we will compare GraalVM JIT and GraalVM native image and see this performance difference. So first I'm running it in JIT mode. That's the JIT mode. And this is a Micronaut application, which is a simple web server that responds to requests. So first I get it to run in JIT. Okay, it's up and running, and we will see it in a second. Also, you may kind of notice that startup time takes 2.2 seconds in this JIT scenario. So it's running, and we will access it in a bit. Okay, here it is. So this is basically its functionality. And let's go back and run it as GraalVM native image. So it's already compiled here. I'm just killing it so I can reuse it. So now when I run it as GraalVM native image, I started as a native executable, and you can also compare in a second startup time and how is it different from JIT. But here it is running and doing basically the same thing, right? So we see that functional, those applications are equal. It's the same application, just running in different modes. But startup time here is 264 milliseconds, while first time it was 2.2 seconds. So it's much, much faster when we are using GraalVM native image. And I think we also have this application in our demos, so this is something you can try for yourself. Now let's go on. One more framework you can use is Helidon. So it offers two versions, Helidon SE and Helidon MP, which is a micro-profile implementation. And also it has GraalVM integration and GraalVM examples. And you can see that also it has startup time improvements, very significant when we are running in GraalVM native image mode. One more is Quarkus. I think you've heard about it. And also I think there is a session about Quarkus and also Micronon here at Devnexus. So make sure to check the agenda. I'm sure that will be interesting. So Quarkus also has those guides where you can easily get started, tutorials, and also you can see that numbers of application in terms of startup and memory usage are much, much lower here in green, where we are using the GraalVM native image mode. And one more is Spring Boot. So Spring Boot has this ongoing integration project with GraalVM. It's called Spring GraalVM Native. You can get it from GitHub. And here on the right, you can see some results that they're sharing of the, well, it's still work in progress, right? But here are some of the results that they already achieved and shared. And they took their pet clinic application, and by compiling it and running it as GraalVM native image, they were able to reduce startup time from 2.6 seconds to 1.16 seconds, and also significantly reduce the memory size. So I think this is something quite interesting to follow and see how they progress and roll out new versions. And also, if you want to try it for yourself, here is a link. I hope you can get the slides, or maybe I can share those links with you in chat. But this is the project. You can take it, build it, and it also comes with those examples. So if you want to try a specific kind of application, you can absolutely do so. Now, what if you want to adopt native image, right? So you are interested, you tried it, and now you want to adopt it. A couple of things that you need to know. First one is that if you're building your GraalVM native application from the ground up, it may be the case that you may need to provide some additional configuration for native image to compile your application. It might be the case if you're using things like reflection. So you can provide that configuration manually, or you can also use our tracing agent that will observe your application behavior and will help you to provide those configuration files that you can later feed to the native image utility to build your application with this configuration in mind. One more thing is performance. So there is an interesting way to optimize native images for the best peak performance, and that is by collecting and once again providing native image information about the profiles of your application. This way, native image can kind of access this information about the application behavior and really tailor optimizations to the way your application will behave at runtime. This way you can achieve really high performance with GraalVM native images. One more interesting thing you can do with GraalVM native images is that if you think the GraalVM native image size, file size is still big, you can compress it even more with something called UPX. So we have a tutorial how you can do it. Basically, there are multiple ways and options and compression level for you to try. But in the end, you can receive a file that is even smaller than a default native image. And when we published this, we saw quite a lot of interest in it from different people. Here are some of the results they accomplished using this approach. For example, here you can see a native image of a Spring Boot application going down, the file size going down from 66 megabytes to 17, which is quite fascinating. And also the similar kind of optimization in the second case, right, from 77 to 23. So give it a try. Once again, this is something that you want to optimize for. And a couple more resources, just things if you want to configure the memory usage, GC options, or understand a bit more about how native image performs behind the hood. This is something, a couple of resources for you to use. And I want to talk a bit about GraalVM language ecosystem. So you remember this slide, right? There are all these kind of languages that you can use with GraalVM. And good news is that you can run all of them on GraalVM. It will still be high performant, so GraalVM will take care of optimizations of the whole thing. And yeah, you can mix and match those languages, and GraalVM will give you optimizations and tooling for the whole thing. So a bit more about languages. You can easily run JavaScript with GraalVM. Our JavaScript engine is compatible with the latest ECMAScript standards, and we are constantly tested against thousands and thousands of NPM modules. And if you are interested in one specific module, you can use this compatibility tool to see if we tested for it and what are the results. And if you've been using Nashorn, or if you're maybe using Nashorn, it's a good way for you, if you're looking for an alternative to it, definitely check out GraalVM JavaScript. You also have this compatibility mode if you want to migrate and kind of to make this journey more smooth for you. Give it a try, and you also try using the compatibility mode. And one more interesting use case talking about GraalVM for JavaScript is that you can use it for server-side rendering of things like React.js and get quite high performance, specifically if you're comparing against Nashorn. GraalVM Python offers you a Python 3 implementation. It's targeting to offer you high performance. I just want to warn you here that Python is one of younger languages in the GraalVM language ecosystem. So there are still some of the things that we are working on in terms of Python. But if you're interested in it, definitely give it a try. And talking about Python, I really like this use case of how we can use it with GraalVM, and what are some interesting use cases that GraalVM enables. And what we see here is a project that was implemented by Oracle NetSuite. And what they did is that they wanted to introduce a new version of their recommender system for their e-commerce platform. And to do so, they wanted to have really good machine learning solution. And they have found some very interesting and relevant libraries in Python. And the way to bridge this gap between their Java application and adding Python there was running the whole thing on GraalVM. One more interesting thing that they did, they wanted to leverage GPUs for better performance. And this is something that you can do with CUDA. So this is a project developed by NVIDIA in collaboration with Oracle Labs. And this is the way you can leverage GPUs from GraalVM applications and languages. And one more interesting polyglot use case. This is an application that shows COVID trends, so very relevant to the world where we live in. And this is a Java application that also uses JavaScript, uses Python to process data, and uses R to plot this chart. So this is how all those multiple languages work together to build one application, and it's fairly easy to implement on GraalVM. Now, I talk a lot about GraalVM and all these different features and use cases, but there are way more. And I just want to share with you a couple of examples of companies who already adopted it and which features exactly out of all those they've chosen and are using right now. So one organization is Oracle Cloud Infrastructure, and they migrated some of their services to GraalVM. The reason to do so would be, in their case, to achieve better performance. And what they observed is peak performance improvements of about 10% and also reduced garbage collection time. And in case you're wondering, this is this JIT mode, right, where the migration is very easy. So they're using GraalVM in JIT mode. Another one, and this is actually also the JIT mode, is that Twitter is using GraalVM, more specifically the GraalVM compiler, for quite some time. And they're using it to run their Scala microservices, and the reason is, once again, to achieve better performance. One more interesting use case, I really like this one, is coming from Dutch National Police. So they used GraalVM in a scenario where they have had a team of Java developers doing application development, and also a team of, I think, data scientists that were working with the R language. And once again, GraalVM here is a good way to bridge this gap between teams that use different languages and different tools, but you can run them both on GraalVM, because GraalVM offers implementation of both those languages and offers a way to kind of approach interoperability between them. And talking about GraalVM native image, Alibaba used GraalVM native image to reduce startup time and resources usage of their application. And this is something that was tested during a very high load period of time. And GraalVM native images in this case showed really good performance by reducing, for example, startup time from 60 seconds to just 3 seconds. Okay, so what if you are curious about GraalVM and what is happening there, what is the project roadmap like, and what is the latest release? So the latest release is 21.0. As I record this video, we just rolled it out, so it's brand new. Definitely give it a try. And if you're wondering which versions of GraalVM are available, we have versions for Java 8 and Java 11. And basically, we have this public roadmap where you can plan for upcoming releases in advance. Talking about the latest release, I didn't have time to talk about all of it, but there is one thing that I want to mention for sure, and that is called Java on Truffle. So Java on Truffle is our JVM implementation written itself in Java, and it is implemented using our Truffle framework, which is GraalVM's language implementation framework. And that's quite fascinating, right? Java implemented itself in Java, and it enables some interesting use cases, such as, for example, embedding one version of Java in another, or mixing JIT and AUT in one application. Okay, and if you want to kind of join the project or influence the project roadmap, one good way is through contributions. As I mentioned, GraalVM is open source, so if you want to learn more about it, you can check our GitHub repo, the first link here. And if you're a Java developer, it should be fairly straightforward for you to understand what is happening there, so definitely give it a try. And another ways to contribution, which I think are less popular, or people talk about them less, is also that you can extend library support, you can contribute to documentation, or even have a meetup around GraalVM. All those ways to support the project are very, very valuable. Okay, so to summarize, what are the benefits of GraalVM and why you could be looking at it? First one is high performance. So GraalVM comes with a new highly optimizing compiler, and it can really optimize your applications for high peak performance. Another one is fast startup that is coming from GraalVM native image. If you're interested in optimizing applications for startup performance, that's definitely a way to go. And one more is easy interoperability and ability to run polyglot applications still with high performance. So give GraalVM a try if you are interested in at least one of those. Okay, so how do you actually do it? You can download GraalVM from graalvm.org. If you're interested in updates, we are quite active on Twitter. And if you want to get help, we have a very active Slack community with a lot of people in there. So please join. That's it. This is my name. This is my Twitter handle. And I think now I will have some time for live Q&A. So it was my pleasure to be here, and see you in Q&A. Thank you.